Okay guys, so today we are here to discuss about one of the most famous problem, a popular one, which is Tower of Hanoi, which we quite encounter in maybe school, like college examination, or maybe in the interview. Okay, so for that, let me open up a presentation. So let me first walk you through that what the problem is. Then we are going to take a look on approach, that how we approach to solve that problem. Okay, so for first, here we are given the three towers A, B and C. We have to move all the disk from tower A to tower C. Okay, but with the constraint that we can move only one disk at a time. Another one, that the larger disk cannot be on the top of the smaller disk. Okay, these two are the condition which we have to follow in order to move all the disk from tower A to tower B. Okay, so next one. So first, our approach, we will approach recursively to to solve this problem recursively. Okay, means we are going to use recursion to solve that problem. So if you know recursion, we know that in recursion we were given a base condition where program would to terminate. Okay, and at first, to solve a given problem using recursion, we have to break it down to smaller problems. Okay, first we can solve the smaller one, then we can solve the bigger one also quite easily. Okay, that's the logic behind recursion, that how we normally solve recursive algorithms. Okay, so we are going to solve this problem recursively. Okay, first, if you have to uh, answer that how to move tower from a single disk from tower A to tower C, then what we will say, we will say just I will move that tower from A to C. Okay, this will be your normal answer. Okay, and that's correct. So for that, the first conclusion which we got is moving disk from tower A to C. This is our first using B. Here B, we are given three towers. Okay, so the first tower is called the no, sorry, last tower is called the destination tower, and the first tower is called the source tower. Means here is the source and here the destination, and the tower B is called the auxiliary tower. Means it helps to move all the disk from A to C. It is the helping tower. Okay, so this is our approach. First, we are going to move a single disk from A to C. So we got to know that how to move that. Okay, cool. Though we are not using here B, but we also have given here just because to make our algorithm simpler. Okay, next, what is there? Now again, now we are given two disks. Okay, here we have to move two disks from A to C. Now what we can do, first we have to move the uppermost disk from A to B. Means the first algorithm should be um, move a disk from A to B. This one we got from A to B. First we have to move that. Okay, then okay, done, we have moved that from A to B. Okay, next one is again move a disk from A to C. Now this one is recursive. Okay, because we have done it here. We are moving the disk from tower A to tower C using B. This one is recursive. This is because we have already done that. Okay, so now we are going to move a disk from tower A to tower C. Okay, this one is recursive. We have already done that. Means we are following this one. Okay, next move disk from tower B to C. Again, this one is also recursive because now we are moving it from B to C using A. Now we are moving it from B to C using. Wait a minute. Now we are moving it from B to C using A, but ultimately we are moving it from to destination C, which we are moving it right here. Okay, we are moving one disk from A to C. Here also we are moving one disk from A to C, B to C. Okay, though the source is changed, but we are performing the same action. So this one is also recursive. Okay, now now lastly we are going to move our B to C. So now we can see our all the disks from A is moved to all the disks to the C. Now we got the algorithm. So how to move two disks from A to C. Next, we have performed two, we have performed one. Now we have to perform this one. Okay. So here we are going to use the actual algorithm which we are going to use. Let's say now we have seen that how to move two, how to move one. Now we can think about something. Okay, to some sort of function or something like that. We know how to move two, we know how to move one. So if we can provide a function that can move two, let's say uh, if there's a function called Tower of Hanoi. Okay, first we can move here two. Okay, this one and this one. Okay, let's say moving it from A to B. Now we will say that how we can move the two disks from A to B. Oh, quite, because we have already discussed that here. That how to move two disks from A to C using that auxiliary tower B. Using the same, we have transferred two disks from A to B using that C. This one is recursive. Okay, so first we are going to move two disks, mean Tower of Hanoi, two disks from A to B, means A is the source and B is the destination, using C, using and B is the destination using C. So this is our first. Then this is the first one. Next we are going to move uh, disk from A to C. Okay, likewise we are doing here. This one is also recursive, we have done it already. Okay, so here we are using that function only. Okay, so again we can write it like this here, moving disk from A to C using B. We have already done that. Okay, it's done. Next, again we are using the function for transferring for moving all the disks from B to C. We already know that how to move two disks from B to C using the second one. Okay, we already know. So again, Tower of Hanoi, we can create a function which can move two disks from B to C using A. Okay, you can see that here we are considering the first one is the source and the last one is the destination, and the middle one is the auxiliary one. Okay, so now we are going to move two disks at a time. This should not be the question that why I am moving two disks, because we already solved that in our second approach, that how we can move two, as we are solving that problem recursively. So this is the algorithm. So we are say moving two disks from A to B. Okay, first two disks from A to B using some kind of function which I have explained here, that how to move two disks from A to C using B. That function I have used here to transform two disks from A to B using the auxiliary function, auxiliary tower C, and then we are moving just one disk. from A to C, just one disk from A to C. Okay, then again we are moving two disks from B to C. Okay, B to C, sorry, yeah, B to C using A. Okay, now let us look at the algorithm. So how many tasks how many disks are there? Three disks. So the basic algorithm should be look like this one. If in a Tower of Hanoi problem, there are three disks. Okay, and we have to transfer all the disks from A to B using A to C, sorry, A to C using some auxiliary tower, let's say B. So first we have to do this one, and then we have to move from A to C, then again we have to come back to this one. Okay, so this is the basic algorithm. Okay, so using that we are going to write the program for Tower of Hanoi. Okay, so now we are going to implement that algorithm in our C program. Okay, so for that, first we are going to write our code, and we are going to review our presentation also, that how we solve that problem, and I'm going to walk you through that uh, how we created the code from that algorithm. Okay, how we can write the code from that algorithm. So for that, first we have to include some basic packages like studio.h, then int main, here, left it here. Now we are going to define that function. Now what that function should take, see here, that function should take first number of disk we are going to pass, 3, 4, anything like that. Next one is source tower, auxiliary tower, and then destination tower. Okay, so for that, first let's just name the function to be Tower of Hanoi, and the first thing which we are going to pass here is int maybe number of disk. So we can take it at number of disk, or and next one is int a, taking that number as 1. Maybe tower A should be treated as 1, B should be treated as 2, and C should be treated as 3. Okay, so this is our problem. First we need to rock solid, means really clear, that the number shouldn't be equal to 0. Okay, so for that we are going to provide one condition, that if number is greater than 0, only then perform this first task, otherwise not. Okay, if number is greater than 0, then only enter into this if condition, and now we are going to execute our program. So first our condition which we are going to see here is Tower of Hanoi 2, means we have subtracted 1 from this one, and then we are moving disk from A to B. Okay, A to B, 2 disks. Here 2 means, it means 2 disks. We are breaking that problem into small chunks. Now you can see why I told earlier that we have to break the big problem into smaller chunks in order to solve the problem using recursion. So we are given 3, now we are providing it 2, again it will go into 1. So we are breaking it into small chunks. Okay, so 2, then A, C, B. Then first of all we are going to write here Tower of Hanoi, then it should be 2, means num minus 1, it will keep on decreasing. Okay, then from where to where we have discussed there, from A to B using C, from A is the same, A to B using C, means there should be C using A to B. We are passing this from A to B using that C. Okay, next what we are transferring, next we are transferring from A to B. Next we are moving this from A to C using B. That's the simple one. we just print that. Okay, because that the solo task every time would be performed. Okay, percentage s, maybe we can write it here as moving disk. How many disk? So we have to use percent d disks from percent d to percent d. Okay, so first thing which I'm going to mention is num, this is the number of disk, and then a, then b, sorry, c. So we can get the source and destination like that. Okay, next again we are going to call that function, as you can see there. Next here we can see here, next again 2 is calling, but now it is moving from b to c as we explained there. Means now again num minus 1 is there, b to c means b is there, a is there, and c is there. Using a as auxiliary, we are moving from b to c. Okay, hope you got that point. Next, if it is done, uh, then we can get the answer. Okay, so now here let us execute our tower of Hanoi for 3 disks. Okay, and a should be 1 2 3. Okay, save that. Let me run that. Let me use some exclamation backslash. Okay, because it is not in the same line. Okay, first here the disk is moved from 1 to 3, then 1 to 2, then 3 to 2, 1 to 3, 2 to 1, 2 to 3, 1 to 3. We got the answer. Moving one disk, first ever it is moved one disk, then 2 disks from 1 to 2. Okay, forgot that we have to just view this one, so we can use this algorithm in our application also, which was this one. You can see here, if you can see it right there, and if I use this algorithm 1 to 3 then 1 to 2, then means 1 is this one, 1 to 3, 1 to 3, then 1 to 2, then here is 1, 1 to 2, then again 3 to 2 means this is 3, 3 to 2, next 1 to 3, next 2 to 1, okay, next 2 to 1, then 2 to 3. Oh, let me, there is one error because I have used it for more than 3, so forgive me for that. We have to use it for 3 only. There's an error. Okay, so let me delete 3 of them below. I forgotten that we have only executed it for 3, otherwise it will not perform well. Okay, yeah, now again trying it. First 1 to 3, this is 1, moving that one from 1 to 3, this is 1, and we're moving that one from 1 to 3, then 1 to 2, this is 1, and we are going to move that from 1 to 2, again 3 to 2, this is 3, 3 to 2, then 1 2 3 2 2 1. This is 1 1 2 3 2 2 1. Okay, then 2 2 3 1 2 3 2 2 3, then this is 1 1 2 3. Now we got the algorithm to move all the dates from A to C using this auxiliary one. So this is our problem, and we solved that using the recursive algorithm. Okay, hope you enjoyed this video. If you like this video, do hit a like and share it with your friends. In case if you haven't subscribed yet, what you're doing here, do go and do and subscribe to my YouTube channel, and do hit that bell icon, and so that you will never miss any update. Thanks for watching this video.